Hey guys, welcome back once again to my YouTube channel. It's McDonald Tech over here. If you're a returning subscriber, please thank you for your loyalty and thank you for returning back to my channel. If today is your first time visiting my channel, please click the subscription button and also hit on the notification icon so that anytime there is a new video, you'll be notified and we all grow together. Today we are looking at the task 0x12C singly linked list. So for this project, this is the concept that we are looking at, that is data structures. So the singly linked list, okay, for we to be able to understand this particular topic well, we need to look at data structures. Now these are the resources that we are supposed to read or watch. So you can read linked list, you can also Google it, then as well you can use YouTube. So when you visit YouTube and you type linked list, you'll be able to have an in-depth knowledge concerning the linked list project. Now these are the learning objectives. So at the end of this project, we are expected to explain to anyone, or we are expected to explain singly linked list to anyone without the help of Google. Then the general thing is we must know is when and why we use linked list versus arrays and how to build and use linked list. So when we come to the general requirements, the allowed editors are the VAI, the Vim, and the Emacs. All your files will be compiled on Ubuntu 20.04 LTS using GCC. Then all your files should end with a new line. Now a README file at the root of the folder is mandatory. Our code should use the Betty style because it will be checked using Betty. Then we are also not allowed to use global variables. And also, you shouldn't have more than 5 functions per file. The only C standard library functions allowed are what we call the malloc, that's memory allocation, free, and exit. Any use of the functions like printf, put, calloc, realloc, etc. is forbidden. We are allowed to use the function putchar. You don't have to push the putchar.c because they will use their own putchar.c for us. Now in the following examples, the main.c files are shown as examples. So when you come to this particular example over here, okay, when you come over here, you can see that they are displaying the content of the main.c, and you can see the example main.c that they are showing us over here. Now we don't have to push our main.c to the repo because they will use their main.c files at compilation. So our main.c files might be different from the ones shown in the examples. The prototypes of all your functions and the prototype of the function putchar should be included in your header file called lists.h. And also don't forget to push your header file. All your header files should be include guarded. Now before you start this particular task, the first thing that we are supposed to do is to solve this quiz. So if you are finding it difficult solving this quiz, you can look at the solutions over here, then you can use that to solve your quiz. So when you are done, then we can now start our task. So the first thing that we are going to do, okay, before you start your task is to launch your sandbox. So after launching your sandbox, navigate or change directory to the root. So you do cd root. Now over here when we ls, you can see that we are in the root directory. Now which of the repository are we doing the task or the project inside? We are doing our task inside the ALS low level programming GitHub repository. So for us to be able to have access to it, you change directory cd into this particular repository. So cd ALS low level cd ALS low level programming repository and hit enter. Now when we ls or we list the content of the directory over here, you can see that all the project that we have done so far can be found over here. So the next thing that we are supposed to do is to create our directory, which is 0x12 singly linked list. So come here and copy the directory name, then come back to your terminal and type mkdir, which is the make directory command for creating directories, and paste the name of the directory over here and hit enter. Now right now when we list the content again, you can see that we now have the directory that we created over here. So the next thing that we are supposed to do is to now type change directory into the newly created directory that we have created. Then you hit enter. Now after changing directory into the new directory that you have created, the first thing that we are going to do is to create our readme file, because the readme file is a mandatory file. So to do that, we type vi space then readme.md, which is markdown. The .md is basically for markdown. So all the readme files are markdown files. Now after entering the command mode with your vi, you hit I on your keyboard to enter the insertion mode. Then you come to the top over here and copy the title of the project over here. Come back to your terminal and type hashtag, then you paste the title. When you are done, you click escape on your keyboard to enter the command mode, then you type :WQ. The W is for saving and the Q is for exiting and going back to the previous page. So when you are done typing this, you hit enter. So right now when we list the content of this particular directory, we now have our readme file over here. Now the next thing that we are going to create is our header file, which is list.h. So to do that, we are going to type vi then list.h and hit enter. Then in the command mode, click I on your keyboard to enter the insertion mode. Then we can type our code. So over here, this is our code for our list.h header file. Now one will ask, where did I get the whole of this code from? Okay, so I'll show you. So it is here. When you come here, okay, when you come to the more info, we are being told that please use this data structure for this project. That is why when you come to this particular place, okay, the whole of this file, this particular script that we have over here, you can see them over here. Now these are function prototypes that I have over here. So I have size t, print list, size t, list length. So this is just the length of the list, that is a linked list. Then list t, pointer, add node, then list t. So these are all the function prototypes that I have, and we'll be creating these functions in the tags as we move along. Now when you come to the size t print list, this is what we have over here. So that means in tag 0 we'll be creating this particular function. That is why we include the prototype inside our header file. When we come to tags 2, which is over here, is tags 1, that's list length. Consider we have size t, list length over here. It's the same thing. So you just copy this particular prototype over here and paste it inside your header file. When you come to tags 2, which is add node, consider we have our function prototype over here. So you copy this same function prototype and paste it over here. When you come to tags 3, that's add node at the end, you see our function prototype over here. So you copy this and paste it over here. Then when we come to tags 4, which is free list, you can see we have our void free list over here. So you copy this and paste it over here. So this is where, or this is how come we have gotten all of these function prototypes in our header file. We just copied it from here and paste it over here because these are the functions that we'll be writing in the tags as we move along. So after typing your function header or your list.h, the next thing that we are supposed to do is to click escape on our keyboard, then we type :wq, which is save and quit, then you hit enter. So right now when we list content of the directory, you can see that we have our two files. So when you are done, we now do git add git commit -n created list.h, then git push. So after pushing to GitHub, we can now create our, or start with our first task. To do that, you come to the down here, then you copy the name of the file, which is 0 print list. Copy it, come back to your terminal, then you type vi, then you paste the name of the file, then you hit enter. In the command mode, click I on your keyboard to enter the insertion mode, then we can type the code. Now let's explain the code that we have over here for your understanding, because we are not just going to do copy and paste. We need to understand every code that we have written over here. Now when you come over here, we are being asked to write a function that prints all the elements of a list T. So when you look at the function prototype, okay, this is printing the list. Now what are the elements? This is the element of what? This is the list T. Okay, so we are saying that the function over here should print all the elements of a list T list. Now what should it return? It should return the number of nodes. So if str is null, then we are supposed to print this nil. Then we are not allowed to use printf. Okay, over here we are allowed to use printf. So in this code we are allowed to use printf in printing our list. So when you come to the code, this include stdlib. We are just including the standard library. Then we are just including the string because we'll be making use of string. Then the stdio is standard input and output header. Then this is our list header that we created. Now when you come here, this is our function header. Okay, this is the type, this is the name, and this is the what we call the function parameters. Now over here we have initialize count to 0. And when you look at the code, the content of the function, we are making use of the while loop. So while h, which we have over here, which is a parameter that we are passing. So while the parameter h, okay, then if h str is equal to null, then we are supposed to print this. So if the content, or if str is null, there is nothing inside, then we are supposed to print 0 and nil. That is why you can see we have our code over here. Else, okay, if it is not null, if it contains a value, then we are supposed to print that value, the length, and also str, the value itself. Then from here we can now update our count, which is count plus plus. Then we now move on to the next value. So it's just a linked list. So when they give us a linked list, okay, you print the first item in the list, the second item, the third item, the fourth, until you reach the end of the list. That is what this particular code over here is doing. So the count plus plus means we now move on to the next item. So the pointer, okay, the pointer will now move on, or will now point to the next item. So if we have point to the first item and we print its content, we now update the counter. So now when we update the counter, it will no more be pointing at or pointing to the first element in the list that we have printed, but rather it will now be pointing to the second element in the linked list. That is why we have this update called count plus plus over here. So when you are done with all of this code, then you can now click escape on your keyboard and you type :WQ, which is to save and quit, and hit enter. Then from here we can now do Betty, then the name of the file to check our code. After a successful check by Betty, we can now do git add git commit -m. Then my message will be created print list function. Then you hit enter. Then from here you can now do git push to. So after pushing to GitHub, we are now done with our first task. Then from here, if your checker has been released, you can now check your code. So for us to do that, okay, for us to check our code, let's create this particular file called main 0main.c, okay, so that we use it to check our code. So to do that, you come here and you type vi 0-main.c, then you hit enter. Then we can now copy their main.c over here. Okay, then you paste over here. Then you hit escape on your keyboard. Then you type :WQ. Then you hit enter. Now when we ls, you can see our main.c over here. But we are not pushing this main.c to GitHub or to our repo. We are only using it to check our code. So for us to do that, okay, the next thing that we are going to do is to copy this particular code over here. Come back to our terminal and paste. Then you hit enter. So for a successful execution, okay, let's ls and see what we'll get. So ls. So for a successful execution, you can see that we have our A inside over here. So the next thing to do is just to type :/ then A, then you hit enter. So you can see that our code has executed successfully. Okay, we are having only two elements, that's hello and world. Now you can see that it has also printed nil before we now come to our world, which is two elements. So over here, when you look at the main, okay, this is the code that executed. That is how come we were able to get these results. So after a successful pass of this particular task, the next one is for us to move on to the next task. But if your checker has been released, then you click on check code over here, then it will check for you. Please do not push your main.c to GitHub, but you can use it to check your code over here. So the next thing that we are going to do, so after you are even done checking your code, okay, the next thing that we are supposed to do is to even remove our 0main.c. So you do rm 0-main.c, then you remove it. So right now when we ls, you can see that we don't have it over here. Then we can also remove our A. So rma. Then when we ls, they are all gone. Because these two, we don't need to push them to GitHub. We are only using it to test whether our code is running correctly or not. So after a successful running of your code, we now move on to the next task. Now what is the next task saying? The next task is saying write a function that returns the number of elements in a linked list T. So this is the function prototype that we already have in our header file. So this is the function that is going to perform, or that is going to return the number of elements in a linked list. So to do that, we need to create the main.c for this particular task. So we are going to type one-main. We are going to type vi, which is our editor, then one-main.c. Then you hit enter. Then in the command mode, you hit I to enter the insertion mode. Then you come over here, then you copy this particular code up to here. Copy it, come back to your terminal and paste it. When you are done, hit escape on your keyboard, then you type :WQ, then you hit enter. So right now when we ls, you can see that we have our one-main.c over here. So the next thing that we are supposed to do is to now create our file, which is one-listlen.c, because it is inside this file I will now be writing our function over here. So to do that, copy the file name, come back to your terminal and type vi and paste the name of the file and hit enter. On your keyboard, hit I to enter the insertion mode. Then we can now type our code. Aside me explaining the code to you, I'll put the links to the code in the description below so that you can click on the link and you also have access. To the code, so that whilst I am explaining it to you, we can all work alongside and follow me step by step so that we all grow together. So the next thing is, after clicking I on your keyboard, we can now type our. So this is our code. Okay, we are being asked to write a function that returns the number of elements in the linked list. So already I explained this in the previous video, the previous task, which is the task 0, that we are only including the header that we created, which is list.h. This we are including standard input and output header, we are including string, and we are including standard library. These are all predefined header files that already C is having. They are all functions that C is having. So we only need to include our own, the one that we created. Then we can now move on to our tags. Now over here, okay, this is our function header. The first thing that you see over here is the function type. Then over here is the function name. Then the ones that are inside the bracket is what we call our function parameters. Now this is just for constant. So our list is constant, then this is our pointer h. So as you can see, we have initialized our count to 0. Now while h, then our count will update, which is ++. Then we'll now move on to the next file. So this one, what we are doing is we are only printing, or we are returning the number of elements in a linked list. So this while statement will execute until our age is now pointing to now. Then this particular return statement will be displayed for us to see. So when you are done typing this particular code, hit escape on your keyboard, then you type :WQ, then you hit enter. Then when we ls, you can see that we have it over here. That's listlen. So to run it, come to the down here and copy this particular code. Then you paste it in your terminal, then you hit enter. So you can see that right now when we ls, we have our b over here. So we can now check the content or run the b to see what it is saying. So we are going to write ./b, then you hit enter. So you can see that it is telling us that we have 2 elements, because that is exactly what we are being asked to write. We are being asked to write a function that returns the number of elements in a linked list. Now when you look at this, okay, when you look at this is just going to print the number of elements. So when we call our function over here, it will only print the number of elements that we have over here. So this is our task. Now if your checker has been released, you can now click on check your code. But before you click on check your code, you have to now use Betty to check it. So 1 dash, then after a successful check by Betty, we can now do git add, then the name 1 dash list, and you add it to your repository. Then you do git commit dash m, then created list element function. Then from here you can now do git push. So when you come to the top over here, okay, they are asking us that we shouldn't push our main.c file. Okay, we will use our main.c files at compilation, and their main.c files might be different from the ones shown in the examples. So over here, what we are doing over here, we are only checking our files to be sure our code is running perfectly. So the next thing that we are going to do is to ls to list the content. Then we can now do rm to remove our main.c file that we have created. And now when we ls, you can see that we have removed that main.c file. Now the next task that we are going to do is to move on to the add node task. Now this task is saying we are supposed to write a function that adds a new node at the beginning of a list. So the prototype that, or the function prototype that we included in our header file is this particular one. So this is the function that we are going to write. This is the function type, the name, then the parameters. Now what does it do? It returns the address of the new element or null if it failed. str needs to be duplicated, so we are allowed to use the function strdup. So the next thing that we are supposed to do is to create our main.c file for this particular task. To do that, you type vi2-main.c, then you hit enter. In the command mode, click I on your keyboard to enter the insertion mode. Then from here, we can now copy this particular file, come back to our terminal and paste. After pasting, click escape on your keyboard and you type :wq and hit enter. Now after doing this, the next thing that we are supposed to do is to now create our file. To do that, you type, or you copy the name of the file over here, come back to your terminal, then you type vi, then you paste, then you hit enter. In the command mode, click I on your keyboard to enter the insertion mode. Then we can now type our code. Okay, so after typing your code, okay, now this is the function we have over here, which is int strlength const char s. Okay, so this is the function that returns the length of a string. Then over here we are initializing our I to 0. So whilst I is not equal to 0, then we now update it. So we are just returning the length of a string that we have. That is why we have the s over here. Now when we come to the down function that we have over here, okay, this is the function that we are talking about over here. What is it doing? This function is adding a node. This function is adding a new node at the beginning of a list. So you can see over here we have list pointer add, then add memory allocation size of list, then if add equal to now, then it should return now. But if add str is equal to strdup, then str. So this is the for the length. Then also we are now adding a new header. Okay, or a new node at the beginning of the list, then it should return add. So the address of a new element or null if it failed. So that is what we are doing over here. So it either returns this null if it fails, or it returns the address of a new element. So at the end it will return add, then to just display the content to you. When you are done, click escape on your keyboard, then you type :WQ, then you hit enter. Then from here we can now use Betty to check our code. So the name of the file is add, so then you hit enter. After a successful check by Betty, we can now run this particular code, which is GCC Pedantic, this particular code. So come here, paste it and hit enter. So after a successful execution, okay, let me clear so that the place will be neat for us to see. After successful execution, type ls to list the content. You can see that now our C, which we have over here, has been created. So to be able to run it, you just type ./C, then we see the content. So you can see that our C has, or our function has run successfully. So from here, the next thing that we are supposed to do is to now do git add, then the name of the file, which is 2-add, then git commit -m created function that adds new node at the beginning. Then you hit enter. Then from here you can now do git push to push your contents to GitHub. Now once we are done with this task and your checker is released, just click on check code, then you will see that your done over here will be checked and it will become green. The next task is task 3, that's add node at the end. So we are being asked to write a function that adds a new node at the end of a list. So the first one that we created, the previous function that we created, it adds a new node at the beginning. But now we want to add a new node at the end of a list. So to do that, we are going to make use of the prototype that we included or we added in our header file. So this is the function that we'll be creating, this particular function. Now what does it do? It's supposed to return the address of a new element or null if it failed. Now str needs to be duplicated. We are also allowed to use strdup. So this is the function that we'll be writing, and the function that we write must satisfy this condition. So to do that, we come to the bottom over here, copy the name of the file, come to your terminal and type vi and paste it. Then you hit enter. In the command mode, hit I on your keyboard to enter the insertion mode. Then we can. Okay, so after typing our code, this is what we have here. Now this particular function that we have over here, what does it do? It finds the length of a string. So this is just finding the length of the string that we will pass to it. Now when we come to this particular place, this is the function that we are being asked to create. We've been told that we should write a function that adds a new node at the end of a list. Now we also said that if str, or if it is null, okay, then that's what, if it fails, then it's supposed to what, print null. So if str or the string is equal to null, then we are returning null. And what does this function do? This whole function adds a new node at the end of a list. Now what does it return? It returns the address of a new element or null if it fails. So if it fails, it is going to return null. But if it passes, then it's going to return the address of the new element. So this is what this particular whole or this whole function is doing. Now this is the type, this is the function name, and these are the function parameters. And these are the statement, or we call them function statements. So when these parameters are passed to this function, then this is what should execute. Now when this one run and it is true, then it will return the address of the new element. But if it failed, then it will return null. If you are done typing your function, hit escape on your keyboard, then you type :WQ and hit enter. Then we can now use Betty to check our file. So Betty, then 3 add node, then you hit enter. After a successful execution, we can now do git add 3 then we can now do git commit -m, then you type created function that adds node at the end, then you hit enter. Then from here we can now push to GitHub. After pushing, we can now create our main.c file to check our code. So to do that, you come here, copy 3main.c, come to your terminal and type vi and paste the name of the file. Then we can now copy the whole of this file. So copy from here up to here. Come back to your terminal and paste. When you are done pasting, you hit escape on your keyboard, then you type :WQ and hit enter. Now when we ls, you can see that we have our 3main.c. Do not worry about these 2main.c. We'll remove all of them because we are not pushing them to GitHub. Then the next thing we are supposed to do is to come here and copy this code and come to our terminal, paste it and hit enter. Now after successful execution, okay, we can now ls to see whether it has executed successfully. Yes, it has. So it has executed and the result is saved inside our D. So to be able to check out the result, let's do .d then D and hit enter. So you can see that our result is looking similar to the one that we have over here. So that means our code is running successfully. So we are done with task 3. Now the next task that we are going to do is the task 4. We are being asked to write a function that frees a list. So this is the prototype of the function that we added into our list.h, our header file. So the type is void, then the name is free list, and these are the function parameters. So for us to be able to write this function, let's write it main.c first, which is for main.c. So copy for main.c from here, come back to your terminal and type vi, then you paste the name of the file, then you hit enter. In the command mode, hit I on your keyboard to enter the insertion mode. Then you can now copy this particular code that we have over here. Come back to your terminal and paste. After pasting, hit escape on your keyboard and type :WQ to write and quit. Now after writing our for main.c, the next thing that we are supposed to do is to write the name of, or is to write our function. To do that, come here and copy the name of the file. Come back to your terminal and type vi and paste the name of the file and hit enter. In the command mode, hit I on your keyboard to enter the insertion mode. Then we can now type our code. Please, if you are facing a blocker along the way, pause the video, restart the video, then follow me step by step. If you need access to the course or the script, it's in the description below. But I'm also trying my best to make sure I explain every script that we write to you, so that you are not just doing copy and paste, but rather you are understanding what you are copying. So this is our code. Okay, now what does it do? This particular function, which is the function that we are being asked to write over here, it frees a list. It releases the memory allocated for a list. So if the head, okay, if head, then free list, head next. Now if head str, then free head str. So this particular function, what it is doing is we are only releasing the memory allocated for a list. So that is why we are saying it frees a list. So we are just releasing the memory. So assuming 10 megabytes was released or was allocated for, let's say, a list A, okay, what this function does is it releases that particular memory allocated for list A. So that is all what this particular function is doing. So when you are done typing, hit escape on your keyboard to enter the command mode. Then you type :WQ to write and exit. Then you hit enter. Now we can now use Betty to check our code. So Betty 4-free list. Then you hit enter. After a successful check by Betty, we can now add this to GitHub. So git add, then the name of the file 4-free list. Now somebody will ask, why am I not doing git add then I add dots? It is because I don't want to push my main.c files to GitHub, because in the statement of the task we are being asked not to push our main.c files because it will not be considered. They will use their own main.c files during compilation for us. So once you are done, hit enter, then type git commit-n. Then my commit message is going to be created a function that frees lists. Okay, so you can see that I mistyped my git commit over here. So I have to type git commit-n. Then I'll now have my created a function that frees list. Then you hit enter. Then from here I can now do git push. Then over here we are now done with task 4. Now we move on to the advanced tasks. Now after doing this, if your checker is released, after pushing it to GitHub and your checker is released, just click on check code. Then it will check your code successfully. The next one is the hare and the tortoise. So we are being asked to write a function that prints you are beat and yet you must allow. Now this will now move this /n, okay, will now move the rest of the content after it to the next line. So I bore my house upon my back will now be displayed in the next line. Then a new line will also be created before the main function is executed. So this is what we are supposed to write before the main function is executed, and we are allowed to use the function printf. So to do that, let's first of all create our main.c that we will use to check this particular code. So copy the 100 main.c over here, come to your terminal and type vi, then you paste your 100 main.c and hit enter. Click I on your keyboard to enter the insertion mode. Come back here and copy this particular code. Then come back to your terminal and paste. After pasting your code, hit escape on your keyboard and type :WQ and hit enter. So right now when we ls, you can see the 100 main.c that we created over here. The next thing that we are supposed to do is to now create our file. So come here and copy 100 first.c. Come here, come back to your terminal and type vi and paste the name of the file and hit enter. In the command mode, hit I on your keyboard to enter the insertion mode. Then we can now type our code. So this is the function that we are being asked to write. Okay, so void, so this particular constructor that we have over here, okay, what does it do? It applies the constructor attribute to my startup fund, which is this. So it's going to apply the constructor attribute to this function. Then this function will be executed before the main. So that is what this particular human being is doing. And this is, so it will apply the constructor attribute to this particular function so that this function will be executed before the main. Now this is the implementation of our startup function. So this is it. This is the function prototype. Then this particular attribute, okay, is the constructor attribute. So this attribute will be applied to our function, which is here. This is the full implementation of the function, so that this will run before the main. So when you are done typing the code, okay, hit escape on your keyboard, then you type :WQ and hit enter. Then from here we can now use Betty to check our file. After a successful pass by Betty, we can now do git add, then 100 first.c, then git commit -m, and created function that executes before main. And we now do git push. So when you are done, we can now come down here and copy this particular code. Then we paste over here and hit enter. So when we ls, you can see that our code has been executed successfully and it has created the first file for us. So to run it, we just do ./ then first and hit enter. So you can see that you are beat and yet you must allow. I bore my house upon my back. So when you come here, you can see that this particular code, okay, is executing before this main function. Okay, that is why, or that is what we are being asked to create. Now for this thing to happen, okay, that was why we apply the constructor attribute to the function that we created in our 100 first.c, so that it will execute. Because if you can remember, you saw that we placed this particular printf or statement in our function before we apply the constructor attribute to it. So it has executed before our main function. So if your checker has been released, the next thing that you are supposed to do is to now just click on check code. Then your code will be checked. Then the last and final script or code that we are writing is real programmers can write assembly code in any language. So write a 64-bit program in assembly that prints hello whole button followed by a new line. So you are only allowed to use the printf function and you are not allowed to use interrupts. Now interrupt also is a big topic on its own, but we will discuss that later in the subsequent videos. Your program will be compiled using NASM and GCC. So to do that, okay, the next thing that we are supposed to do is to copy this particular file. Come to our terminal and type vi and paste it and hit enter. In the command mode, hit I on your keyboard to enter the insertion mode. Then we can now type our. So this is our assembly code. Now this extend printf, okay, you can see the statement over here. This is the save function to be called. So the extend printf, this is the save function that we are calling. Then this is section data. So this is just for the data section, okay, initialized variables. Now this is the string. That's why you can see msg, that's message. So db hello whole button. So this is the C strings needs what? 0. That is why when you come over here, we have our, they are being asked to write a 64-bit program in assembly that prints hello whole button. Now this is the section test. So this is our code section. Now the global main is just the standard GCC entry point, because it will be compiled using GCC, so we need an entry point for it. So this is the standard GCC entry point. Then the main over here, okay, is the program label for the entry point. Now where we have the push RPB is what? Setup stack frame, and this must be aligned. Then we have move. These are all assembly languages. Move RDI FMT, then move RSI MSG, then move RAX 0, then we have call. So all of this, okay, move, call, pop, return, these are all assembly codes. Then the pop over here, we are popping from a stack. So pop RBP is just saying we should restore the stack. Now when we call printf, we are calling the C function. Then move RAX, okay, is normal, no error, or we are returning the value. Then RET is basically for return. So this is our assembly language or code. Then when you are done, you click escape on your keyboard, then you type :WQ to save and quit and hit enter. Then we can now do git add, then 101. Then we now do git commit -m created assembly language in C. Then you now do git push. Then over here, the next thing that we are supposed to do is just, so when you are done, after clicking on enter, come here and copy the whole of this code. Come back to your terminal and paste it and hit enter. So you can see that it has been executed successfully. So for us to see or run the hello, you type ls, and you see that we have our hello over here. So to run it, you type /, then hello, then you hit enter. So you can see that our assembly language in C has been run successfully. So now, since we don't need our main.c files, we can now do rm 100.main.c 100-main.c rm 2-main.c rm 3-main.c then rm 4-main.c. So right now when we ls, we don't have our main.c files over here. So I can now do git add, git commit -m, then updated. Then I now do git push. Okay. So when you are done with this task, then you can now come here. If your checker is released, you click on check code, then you are done. So this is how you write or you code this particular task, which is 0x12 C singly linked list. Please, if you are following and you are facing a blocker, restart the video and follow step by step so that we all grow together. If today is your first time visiting my channel, please smash the subscription button and click on the notification icon so that we all grow together.